Hello Java programmers. In this video we continue with our discussion of hash tables and look at a complete working example that processes data from a file into a hash table and then manipulates the hash table. You should have downloaded this file from the LMS and then you can follow along, and I will ask you to make modifications as we progress through the discussion to improve your skills. So stop the video, download the project, import it into Eclipse if you've not already done so. This project has two packages. American Athletic Conference. It contains a class called American Athletic Conference, which models a school in the sports conference of our beloved university. And it also has a main package which contains a main. The main simply invokes a couple of methods from the American Athletic Conference class. There are also three data files. American Athletic Conference.csv provides the information that we need to populate our hash table. The other two data files can be deleted. We do not use those. In this example, you don't have to look at those. You might be able to open the CSV file in Eclipse. On my machine, Eclipse is configured to load that into Excel. It's not an Excel file per se, it is a CSV file, but Excel knows how to process that into what looks like a spreadsheet. You're welcome to do that if you'd like to take a look at the data, but do not think that it is strictly a spreadsheet. It's not. Eclipse also wants to do something else with the file. I'm going to say cancel because I don't want to add things or extend things that are part of Eclipse. If you go to the Windows browser and you navigate to where you stored the file, and apparently I'm not sure where I stored the file. There it is. You can see that the files appear to be associated with Excel. If you have Excel installed on your machine, then Windows thinks those are Excel files. If you have a text editor like Notepad++, that has some color in it, Notepad++ will show you the actual raw content of that file. It's simply comma separated values broken up into individual lines of text. And we have a way of separating those inside of our Java program using commas as delimiters. Let's take a look at the class, American Athletic Conference. It has some private members, nothing new there. Each private member has a getter and a setter. In the real world, not all private members will have both getters and setters, but we don't have a lot of context, so I simply provide a getter and a setter for each property. I also built a constructor that uses all the properties of the object. School name, city, state, year, founded, year, joined, is private, enrollment. Oh, is private is in there twice. And a nickname. So that JavaDoc is a little bit messed up because I see that I have is private in there twice. I would normally just take that out, but since you're downloading this program from the LMS, I'll leave it in there so yours looks exactly like mine. The constructor is correct. School, city, state, year founded, year joined is private, enrollment, and nickname. The only way you can create an instance of this class is to call this constructor. There is no default constructor. There is no constructor that takes 0 arguments. You must provide all these arguments. And I provided a toString which simply combines the school name with the city, state, the nickname, and the year it was founded into a string. That was arbitrary. I could have written that any way that I like. I just chose to use those properties of the object. At the bottom, we're getting into the good stuff. We have a method that reads from the CSV file and stores the data in a hash table, and the value of each element in the hash table is an American Athletic Conference object. The key is going to be the name of the school. That's our hash table. So you should take a close look at this, and you can see that we open a file, we stay in a loop as long as there are lines to read in the file, and we execute what's called a split on a comma. That's where the CSV file becomes valuable. And that split method divides that line of text according to the commas found in that line and puts each individual part of that line delimited by commas into an array of strings. That's why CSV files are so valuable, because we can easily split on commas. Once we've got that array of strings, it's trivial to call the constructor and pass it individual elements of that array, because we know the individual elements in the array are the individual parts of that line from the text file split on the commas. In a couple instances, we have to convert data types because everything that comes from a text file is a string, but we know that some of those values are actually numeric and one is in fact a Boolean. We call the parse int method or the parse Boolean method to convert from a string to an integer or a string to a Boolean. Once we've created an instance of American Athletic Conference, which we're calling team, we call the put method on the hash table using the school as the key and the team object as the value. That builds a list of teams, of schools, universities, in the form of a hash table. Looking down the road then, we can look through or look up instances in the hash table using the key, which is the school name. And we know that school name will be unique because there won't be two schools in the same conference with the same name. That's just not going to happen. We've created our little tiny elementary baby database by adding things to a hash table using school name as the key and the team object as the value for that key. If we look back over to the main, I create a hash table. Notice in line 15, I do not instantiate it because it will be instantiated by the read method that I'm about to call. And then I create an instance of the team class. I put that instance of the team class into the hash table called my conference, and I've got a hash table with one element in it, and that's simply this school UC that I created up above. And that's pretty trivial. That should look familiar. We did that in a previous video, simply to get us going again. The good stuff is down here. I use the same type of thinking where I create a hash table. The key is a string, which will be the university name. The value, according to that, associated with that key, is an American Athletic Conference object. And then I call the read from CSV file method, which populates a hash table by reading the file, processing the lines in the file, creating objects, storing them in the hash table, and then finally that method returns the hash table, which is stored in my conferences variable. And then in line 28, I just do a print statement to make myself feel better and prove to myself that something actually worked. Let's run this, and it should be the number of rows in the CSV file. It tells me that I read 11 teams from the file. Let's validate that. I can go back to AmericanAthleticConference.csv in the Project Explorer. I can double click on that. As you saw before, it loads Excel, and there are indeed 11 rows in that file. I read 11 rows, but with my program, there are 11 rows in the file. I'm probably okay. By the way, let me backtrack just a moment. When you open this file in Excel, and you may make changes to it, you may widen a column, who knows, you may be tempted to format something. If you hit save, it wants to save it as an Excel file. Okay? So be careful, because if you save it as an Excel file and you clobber that CSV file for whatever reason, you're not going to be able to run this program anymore. My program will crash because it's assuming that you're providing a CSV file and you're providing an Excel file, which is actually XML. Don't do that. At this point, we've seen everything that my program does. I'm going to ask you to make some modifications to it so you can practice. The first modification is indicated in the comments in line 30 of main.java. Iterate over all the entries in the conference's hash table and print the toString for each value. You need to figure out how to iterate over a hash table. That was shown to you, that was demonstrated in one of the previous videos in this module, or you can go online and look for it. Either way, I want you to go ahead and write that code, and I will wait for you. Are you done? If you aren't done, stop the video and finish. This is important. You should try to figure this out. Don't give up so easily. I'm going to continue. Here is a solution. I create another data structure called a set, and a set is a mathematical construct that's reflected in Java. If something is a set, it means you cannot have duplicate values, so it's a convenient data structure to use when we're manipulating a set of keys. This set of keys is populated by calling the keySet method, and you can see the Java docs for the keySet method says returns a set of the keys contained in this map. A map is something generic, it's a type of collection, and a hash table is a type of map, so just wherever you see map, think hash table. Once we've got the keys, we can iterate over the keys using a ForEach loop. Now, looking ahead a little bit to next year, or to C#, we use ForEach as a syntax, but in Java it's just for, and it's called an enhanced for loop or a ForEach loop. This enhanced for loop lets us iterate over the keys set, and each time it goes through the loop, it will initialize that variable key to the next key in the set. Then in the loop, we can call the get method on the conference's hash table. The get method returns the value associated with that key, which is going to be an American Athletic Conference object. Now, once we've got that, we can call the toString on it, because we know that an American Athletic Conference's object has a toString method because we wrote it. You may want to think about it this way. If I put parentheses here, what we're doing then is we're executing this get first. We know the get returns an object of type American Athletic Conference. Once we've got that object, then we're invoking the toString on that object. And that's the toString that I wrote in the American Athletic Conference class. When I run this, I should get 11 lines of output, one for each of the toString methods that I'm calling on the elements in the hash table. Let's see what I get. And there it is. The first entry is University of Tulsa, and then SMU, and then South Florida, all the way down to the University of Cincinnati. I don't know what order that is. I'm curious, and I hope you're curious. I'm curious to know if that is the same order that was in the CSV file. Let's take a peek. Again, just double click on the CSV file. Hopefully it launches Excel for you. And the first element is UCF, Central Florida. The last element is Wichita State. You see a second from the top. That is very different from what we got. And remember from our previous discussion of hash tables, we're not guaranteed any order. The order we put them in is not guaranteed to be the order we get them out. Reverse or ascending or descending. That's perfectly fine. A hash table is not sorting it. It's simply storing it by key. Everything looks fine. All right, I'm sure you got that one figured out. The next thing I'd like you to do is, let's say, add another element to the hash table. Let's see, a new university is joining the conference. It will be Claremont College. It is in Batavia, Ohio. It was founded in, I don't know the exact time, 1982? I don't know. No, before that, I believe. 1979, perhaps? It joined the conference in 2020. It is not private, sorry. It is not private. And the zip code is 45103. That's not the zip code, sorry, that's the enrollment. Enrollment is, let's say 3,000, that sounds about right. And the nickname is the Cougars. Does that give you everything you need? Claremont College. Oh, it needs the city and state. Let's sneak that in there. That is going to be Batavia, Ohio. And there's no comma there. And what I want you to do then, of course, is write logic to declare and instantiate a new object, add that object to the hash table. Work on that now. If you need to pause the video, please do. Here's mine. I declare and instantiate an object called UC Claremont. Seemed like a good name at the time. I pass it school name, city, state, founded, date, joined date, false because it's not a private school, enrollment of 3,000, nickname of Cougars, all to the constructor. The constructor initializes all the private properties of that new object. Now I have an object called UC Claremont. In line 53, I call the put method on the hash table, which adds that new object to the list of schools in the conference. And using the get school method, I provide the key for that entry into the hash table. And that gets the job done. That's what I asked you to do. To make sure that it worked, I added the same logic that I had up above to print by iterating through all of the elements in the key set. And you can see this isn't quite finished because I already had something called keys up above, and it gives me a duplicate local variable. That's easy enough to fix. I can reuse the keys that I created up above. Don't have to declare it again. Then I call the ForEach, or the enhanced for loop, just like I did above, and iterate through the list of schools. This time I should get 12 schools because I had the original 11 that I'd read from the file, and I tacked on another school, UC Claremont. Remember that when you run this, if you haven't made any other changes, you'll still get the original 11 in that print statement in line 32, and then you'll get the new 11, or the original 11 plus the new 12 in the second print statement in line 57. Let's see what we get when we run this. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Actually, that's a little bit hard to read. Let's go back and let's comment this out. We don't need this anymore. Let's comment out that print logic in line 33 because it's just cluttering up our output. And we could comment out line 32. We don't need that. Now let's run it and get something we can look at. Uh-oh, what did I do wrong? Hang on. I see what I did. I need line 32 because that's where I declare my key set. And I commented that out. I got ahead of myself. Now I'm okay. Let's run it. There we go. There's 12. You can ignore this because this was from the first time we read from the data file. We got 12 entries. Notice where UC Claremont ends up. It is 1, 2, 3, 4, 5 from the top. Even though it was the last one that we added, it somehow got stuck near the middle. No rhyme or reason for it. That's just how it works. We're not guaranteed any ordering. The next thing I'd like you to do is, let's say that SMU dropped out because they cheated in football and they are on suspension. I want you to delete SMU from the list, from the hash table. Okay, go ahead and work on that, please. There's my solution. I call the remove method. I pass it the key. It looks up the key in the hash table and removes the entire key and associated value from the hash table. I could print out the entire hash table to see if it worked, but I know that there's 12 elements in the table right now. Therefore, I'm going to print the number of elements in the table which is conferences.size. That should print 11. I started with 0. I read 11 from the file. I added 1, which gave me 12, and then I deleted 1, which should put me back to 11. I'm back to 11. I'm fairly certain that I deleted SMU or I deleted something from the table. Good. Hopefully you're able to get that to work as well. That brings us to the end of this video. I encourage you to watch it as many times as necessary and practice to get a good feel for what we're doing. This is important programming technology that applies to different programming languages, not just Java. We have to manipulate data types no matter what kind of programmer we become, or cybersecurity expert, or network manager. Everybody has to write some code now and then. Everyone has to deal with objects and collections of things. Be careful, work hard, ask questions, and we'll see you in the next video. Thank you.